All right, hello again. This is Jeff Scott. I've been doing some presentations regarding the Microsoft Security Development Lifecycle, and I just finished one on cross-site scripting, or XSS, and now we're going to go into another presentation. This one will be very short, which is on cross-site request forgery, which is also known as CSRF. What we'll talk about in here is a definition of CSRF, kind of a compare-contrast between cross-site request forgery and cross-site scripting. Talk about a couple CSRF attack examples, and then finally some prevention mechanisms that you can use. Like I said, this is a very short presentation. So, as mentioned here, CSRF is an attack that forces an end user to execute unwanted actions on a web app in which they're currently authenticated. All right. Specifically, these attacks target state-changing requests. They're not trying to steal data, because the attacker has no way to see the response of the forged request. Basically, as mentioned right here, the attacker uses CSRF to trick a victim into accessing a website, or clicking typically a link, or sometimes even just going to the point of putting their mouse and hovering over a link. And that link is what contains the malicious or unauthorized requests. You've heard of stories like this. There have been stories in the past where, for instance, years ago, and I know my kids were hit by this, that there was some kind of a picture of Beyonce in concert that somebody started sending, and everybody started to download it. The problem was that the picture had embedded in it, it had malware. All right. So if you clicked on the link, it would embed malware into your machine. That's kind of what we're talking about here. Again, as mentioned, the CSRF attack uses the identity and privileges of the victim and impersonates them in order to perform actions desired by an attacker. All right, so let's kind of compare and contrast CSRF, or cross-site request forgery, with, and that's backwards. That's CSRF. I was wondering why that looks so funky. All right. So let's compare CSRF, cross-site request forgery. Let's compare and contrast that with cross-site scripting. All right. With cross-site scripting, we already had a presentation on that. The attacker exploits the trust the user has for a website. All right. But with cross-site request forgery, the attacker is exploiting the trust the website has for the user. All right. In order for this type of an attack to work, the user must be authenticated with the target website. So there's a login type of process that takes place. Assuming that happened, the attacker can include a link or a script in a third-party website. Now think about this. Typically, if you have to go to all the trouble of logging in to be able to see something that's on a site, most people would think that, well, it's probably pretty secure. So, as mentioned, the victim visits the website or link. There's a rogue script that they execute because the victim doesn't even think that there's any problem with it. Here's an example. In a chat room, an attacker could post a message that contains an image tag or an HTML image element. There was just a story on the news recently about some attackers from another country that had gone in and had breached data from people at all sorts of financial sites. And what they would do was, when those people would log into their sites, they would basically send things to them. They would have stuff embedded in there saying, hey, you might be interested in this type of thing. And it wasn't so much malware in this case that they were putting in, but what they were doing is they were encouraging them to buy penny or cheap stocks. And people were doing it because they were inside of the website, they were logged into the website, of some place they trusted, so they were going in there, and I guess from what I understand, millions of dollars took place, and people were buying these penny stocks. Then the people who were the attackers, they had also bought these stocks, but then when the price went up because a lot of people were buying them, they dumped them. The price went back down again, and these people who had bought the stocks were left holding the bag, so to speak. All right. As mentioned, quite often this will be in an image tag, and I already gave you an example of that before. The image will have a link that performs the action. There's an example of sending it to a bank account or something like that. So rather than getting an image, the attacker has included a link that might perform some kind of a bank transaction for them. It'd be something like this. Now, it's a little bit convoluted of an example because, the account holder's name won't be Bob, and Bob probably won't have $1 million, and they probably won't give it to Fred, but you get the idea, hopefully. So as it says, this is a CSRF attack that uses a GET request. And many people think, well, if you have posts, with a GET request, remember that all the information is included inside of the address string or the query string that's up in the address bar. People think, well, if you put them into a post request, since they don't see that, that'll fix the problem. But it's still possible to perform a CSRF attack using a post request. So what won't work for this? Well, some people, again, think if you use a secret cookie that'll work, but it won't because all cookies are submitted with every browser request. As mentioned, some people think that accepting only post requests will work, and it doesn't. Multi-step transactions. People think if they break it up over different steps that it'll work. Well, it will as long as the attacker cannot predict or deduce each step of the transaction, because if they can, a cross-site request forgery is still possible. URL rewriting, kind of making pretty URLs, where you cut down some of the information that's shown. And that's better, but the credentials are still exposed over the URL. If nothing else, when the user goes in there and does a right mouse click and does a view page source. So what will work? Well, what will work is using some kind of a synchronizer token pattern, because this generates a series of random tokens. And it's more or less along the lines of, it makes it because the user can now not figure out the order in which things will happen. So, as mentioned here, this is analogous to making the attacker guess the target victim's session identifier. Like I said, this was going to be a short presentation, so that's it.